Okay, so we are going to resume our recording now by continuing to the next session. All right, so the focus this time around will be how you create your foundation plan in Revit. Sorry, in AutoCAD. My mind is in the Revit class. That was yesterday and tomorrow again. All right, so we're going to be looking at that. Now, if you remember, when we started our floor plan, one of the things that we did before we start creating the openings for our doors and our windows, we had made a copy of the layout of the building. So right now we have the walls for the foundation plan already, which means that those walls would be coming from out of the foundation plan, from out of the ground rather. So because we don't need to excavate the ground for our closet walls, I would have told you before you put in your closet walls, these are non-load bearing walls. I don't need to excavate foundation to have those walls coming out of the ground. So before those walls were added, before the openings were created, we made a copy of those walls and paste them over here. All right. So let me jump back over to the presentation, handout, the manual. We're going to look at our foundation plan and give a brief discourse on why we are using that particular foundation for the building. All right, so this was the ending of our dimension from the previous session. So we're going to move over now. So our floor plan, when it is complete, should look like that when all our dimensions are in place. So you can use the manual as your guide to know where those dimensions need to be, okay? But right now, we're going to be focusing on the foundation plan. So I would have given you a definition for the floor plan. So I'm now giving you a definition for the foundation plan. So while it is that the floor plan was a horizontal section going through the building above window sill, your foundation plan is also a horizontal section going through the building, but this time it's happening below the level of floor. So if you cut through the building below floor, then you can't tell where your door openings are. You can't tell where your window openings are because the walls are just coming out of the ground. So you're cutting the wall across. So the two inner lines, which are continuous lines, represent the walls coming out of the ground. And the two dotted lines that are parallel on either side represent the actual footing that the wall sits on top of, the foundation footing. So this, as we will talk about later on, is a narrow strip foundation. And we will look at in situations where this kind of foundation is used. And I know you would have had that discussion in your technology class. So that this is just a recap to ensure that you understand what we're doing. So these dotted lines represents the foundation footing, which is underneath the walls. Now, the reason why they are in dotted lines is because if you're cutting, your cut plane will happen above the level of your footing. So when the backfill takes place, that means the earth is now poured back into the opening where the trench was against the wall. You would not be able to see the foundation footing at that level way down there. So you would now represent it in dotted line because they will be hidden. All right, so let's look at a typical cross section of the foundation that we are drawing. So this is a typical footing, which is called a narrow strip foundation footing. So a narrow strip foundation basically is where the width of your footing is maximum 3 times the width of your wall. So our wall is 150. The projection on either side is 150, 150. So this is 450. But that's what we call the projection. It could be greater, but it cannot be less than the In this case here, well, I think I said maximum. It could be more overall, but this distance here is minimum 150 because your block wall is 150. It could be more, but not less than that, right? So right now it is 450, which is 3 times our block wall. Likewise, the depth of the foundation footing is minimum the same as your projection. So it can be 150, but not less than 150. It can be greater. In our case, it is twice the 150, it's 300. All right. So this kind of foundation, which is called a narrow strip foundation, is recommended where you have good firm soil, good firm strata. Now, what do we call good firm soil? Maybe you have like red dirt, you have your black soil, black dirt, sandy loam, good firm strata, not anything that has water in it readily, like a swamp area or any clay type soil. So this is not recommended for clay. Since I mentioned the word clay, I'm just making it outright right now. So everybody understand that this type of foundation is not recommended for clay. So we're going to talk about some other types. So right here, we are seeing the narrow strip here under these walls. This one is called deep strip. This one is recommended where you have clay. You see, clay has this very unstable behavior. When the rain falls, it soaks into the soil and the soil swells. Then the sun comes out, evaporation takes place. All of that moisture is now dried out of the soil and it shrinks again. And this is why the clay tends to have this crack. It have a lot of crack in it because it's always moving. So what you don't want is to use a narrow strip foundation in a soil like that, where there is always some kind of movement. And the resistance, the area that is holding against the soil on the side is not enough friction to hold up, even though it's holding underneath, but you need some forces to be acting against the side here. So with a deep strip, you have more surface area for the soil to act as friction against the side of the footing. So because of all of that uneven movement and the behavior of the soil basically moving, settlement you don't want to take place and then the foundation shift. So you want more friction against the side of the thing on both sides as well as your end bearing. So we tend to use deep strip in a clay type. I can tell you that most people out there usually resort to deep strip. Sorry, narrow strip and not the deep strip. So that is why sometimes we have some cracks in our walls, because when settlement takes place and the wall slips, that means it's moving, then it causes the walls to crack, and you see the crack from the floor up to the window sill and sometimes elsewhere in the walls, and that's problem. All right, so we use deep strip. Not going too deep. Your technology class should go a little deeper than that, but just to give an idea what kind of foundation is recommended for the type of soil. Of course, if you're doing a commercial building, it is recommended that you do soil tests. So you get a soils engineer to come in, take a sample of the soil, go to the lab, test it. They do the calculation, and they will determine based on the bearing capacity of the soil and the amount of load that is going to be exerted on that strata, the earth. Then they will determine the type of foundation. So these are like recommendations based on typical building size, or you can recommend what type of foundation is suitable. So this one now is a raft foundation. Now before I go into the raft, just to say that you can have a wide strip foundation. Let me just jump over because I think I have a slide that shows an example of that. A wide strip. Okay, this is kind of what a wide strip will look like. It's a little wider than the other one. So with the wide strip, because the narrow strip will stop closer, what tends to happen is that in those soil, what we call man-made soil, man-made built up, those reclaimed land, those lands that were once maybe swamp land, and you dump them up and you compress it and then you start building it. Maybe, like most of what happened in Portmore, some of those lands were once swamp land, and then they dump them up and have them as housing development. So those are not natural soil. Natural meaning the way how it was formed from maybe creation or wherever over the years where sediment take place and it built up and create naturally. We're talking about where soil is placed there, it compressed, and then it's now used for that purpose. So you tend to have some voids or pockets in those soils. So what you want is to have a broad surface to float, like how a boat will float on water, because you have a wider surface area, so it floats. So if we get those kind of soil with a wider base, then even though you might have some pockets underneath, you can have this floating on top of that soil. So what is happening is that your raft foundation, this is an example of your deep strip, a cross section of it, but and this is basically showing you where you would excavate the foundation and have, this is like blinding in the foundation before you cast the concrete, and then you would put in your steel and coming up, right? So this is just a layout in picture. We'll go back to this slide. The reason why I discussed the wide strip before is because I want to show you that if you have wide strip and your walls are very close together, you're going to realize that the foundation literally maybe start overlapping. So the recommendation would be using your raft foundation where it covers the entire area, and you don't have to create a floor because the top of because it's like a slab on top of the ground, and then underneath the walls now you'll have the foundation going down like this. So your raft foundation is like wide strip combined going across, right? So you could use that. Then we have the pad one that goes underneath the column. These are independent foundation that will take the load of your columns where you have those frame structures, beams and beams on columns, where the transferring of your load is coming from the roof down the walls, or down from the roof into the beam, down through the walls, or down to columns. If you don't even have walls yet, let's say it's a frame structure, so you go into from the roof to the beam, down through the columns, then into the floor, then into the beams, then into the columns, all the way down to the foundation footing. So the walls that are built in between those columns are non-load bearing walls. They would have their own foundation just to carry their own load. But these are the pad foundation for those isolated columns structures. And then you have the pile, which is recommended where you have the waterlogged area now. So you have swampland or water along the coastal shore. You would drive piles until you get to firm strata. So all those buildings on the coastal shore, like down on the waterfront downtown there, we have the Digicel building and BOJ and all those buildings. The foundations that would have been used for those buildings would have been pile foundations. So they would drive the piles all the way down into the ground through the water until they hit firm strata. And then no, so they will be driving piles for maybe months before they can start building the building, because they have to hit some firm strata. And then no, they would cap the top of it to create a floor, like, so to speak, like how you do the raft. And then no, on top of that, you would build your building, right? So you would treat with your pile. You would have gone deeper with it in your technology class. So just to give you an idea which one is recommended. So this is the slide that we looked at before. This is the narrow strip. So you would have the earth itself, where the foundation is here. The backfill would go back into there, and the wall that comes above the ground, which is what we call superstructure from floor up, and from top of floor going down is what we call the substructure. So these are walls coming out of the foundation. All right. This is the narrow strip we looked at before, and this is the wide strip. And this is an example of how a raft foundation would look, because you would have your walls going down, tie into your floor, and then later on now you come back and build your walls. So you would have your floor basically finished before, and then the walls go on top of that. All right. So we are going to, after the break, because I only have 2 minutes left into this session before the recording goes to an end, and then we'll come back and look at how we do the foundation plan. All right. So that was just the lecture portion of it, or the tutorial. And then now we are going to move over into the actual thing. So I will just explain what's going on here first, and then we will do it after the break. So what we're going to do is to select the entire thing and turn them back into polylines so that we can offset them one time. All lines that are touching will offset together. All right. So let me go ahead and stop the recording now in preparation for the next session.